Hi y'all. This will be a very, very short video because hopefully it is all review. There's literally just one new thing and I'm going to do one example and then you're going to have to do a whole 3 problems and that'll be it. So I was going to only do 2 things this week, but I figure we probably need to do percent composition one more time and you'll see why. So what we've done up till now, FYI, just a reminder, percent composition, the definition is the percent by mass of each element in a compound. That's what we're really going to do today. Or really it's part out of a whole. Again, that's what we did last time. The actual chemistry textbook definition is the second bullet. The mass of each element compared to the mass of a compound. Actually, that's the first one's the textbook definition. The second one is what we do. Or it should say the mass of each element divided by the mass of the compound. So really percent composition is the grams of the element divided by the grams of the compound. Again, times 100 because that's what you do for percent. There's 2 ways to calculate percent composition. The first way is the one we've done already. We didn't know what the formulas were when we did percent composition. We hadn't even gone over formulas. So this is the exact same example you guys have in your notebooks that are sitting in my room. So percent composition, you got 2 elements. 20 grams of calcium and 42.5 grams of sulfur. Remember, percent composition is part out of a whole. So now this is what people did wrong. Unit 4 test, probably you guys that are still hanging with me, probably made this exact same example. Each of those individually is the part. When you add them together, that's the whole. Most people did 20 divided by 42.5 and they got it wrong because there are 2 separate elements. So, calcium, 20 grams. You add them together for the whole is 62.5. So that's 32%. Sulfur is, well, it just clicked really fast. 42.5 divided by 62.5. The bottom number is the same the whole time. So the first one, when you don't know the formula, you're going to have one problem like that. The next way is when you know the formula, because this is curiously similar to, well, you do molar mass for crying out loud. So here's my formula I gave you. FYI, the name of this guy is barium phosphate. So you still have to do, look, each of these individual elements is not just one. So sadly, you have to do some multiplying. So it's still part out of a whole. Grams of each element divided by grams of the compound. So what I do when I do this is, you could add them all up, but then you have to, so I do each element, the top number first, like each element individually, and then I add them all up for the bottom number. So first off, we have barium. There's our first element. That I did this is an old PowerPoint, so it's got an extra number in. I bet you yours is 137.33 times 3. So you get that number. Then you did phosphorus, 30.974 times 2. That's that number. These are all the top numbers. Oxygen is 50.999. That's really what it is, but we round to 16, which is so much easier. But that would round to 128. 16 times 2. So there's all the top numbers. So gee, how do you get the whole? You add all those up. So the formula for barium phosphate, so all those added up, 601.921. That's your bottom number for every single one of these. So 411, I hope I'm not going too fast, but for crying out loud, we've kind of already done this before, but I wanted to do it again. Real fast. So today's going to be really easy. So there's a part divided by a whole. This one I left the extra decimal point. It's not a big deal. But you just divide them. And I did the times 100 in my head because when you divide 411.981 divided by 601.921, that's what you do. Okay, so I actually did a practice problem that I'm going to do right now with you. So what is the percent composition of each element made of? Let's see if it's going to, it writes in red. I want it to write in, PowerPoint. There we go. I would like it to write in white so you can actually see it. Well, white's not there. How about yellow? Okay, so, there's no formula, so each of those is the part. So silver, I'm just going to do Ag equals 29.0. There's the top. Sulfur is 4.3. So G, the bottom number is 33.3. It's going to be the same bottom number for both, times 100 times 100. And I have to punch this into a calculator. 29 divided by 33.3, 87%. 4.3. And gee, I bet you this one's whatever. 87 minus 100. 0.129, so 12.9, so that'd be 13%. Not so hard. Next practice problem is just another one with a formula. So percent composition of each element. So there's 1, 2, 3, 4 elements in here. So calcium is, well, I don't know what it is. It's like 40.01, or maybe it's just 40, but it's 40 for crying out loud. So calcium's 40. Here's all the top numbers. Carbon is 12 times 2. 24. Hydrogen is 1. Oh no, wait, there's 2 times 2, so that's 4. Dang it, 12 times 4. 12 times 4. 48. Carbon is 48. Hydrogen, again, there's 3 times 2, so that's 6. That's 6. This is me rounding to a whole number because an oxygen 16. I guess I can squeeze that in. 16 times 4 is 64. Okay, so great. Then you add all those numbers up and you get your bottom number. So 64 plus 40 is 104 plus 48 plus 6. Bottom number is 158. And that's all you do for percent composition. 40 divided by 158, 25%. 48 divided by 158, 30%. 6 divided by 158. Okay, ready? I got 0.0379. You move the decimal over 2 places. 1, 2, that's 3.7. So 4%. 64 divided by 158. 40.5. So 41. This might be 1 over, but maybe not. So I bet you if you add them all up, you get 100. There you go. We could do one of the using percent composition problems, but I'm not going to worry about it. Now, this is really just a refresher. Hopefully you get these all right. Hopefully it's really easy. The next 2 things. Tuesday, tomorrow will be empirical formula. Wednesday will be molecular formula. Empirical formula is how we get the actual formula of a compound, not just, well, I'll tell you tomorrow. It's fine. So we'll see you guys later. I did get, and I'm going to send out a poll here too to figure out what's a good time to do like a Zoom so you guys can ask me questions like live, which works really well. For the 4 people that came to my last one, they got all their questions answered. Okay.